Yeah, good evening, Surya. Good evening, online students.
Good evening, ma'am.
Good evening. Yeah.
Good evening, ma'am.
Good evening, children. Good evening. So, in this chapter, algebraic expressions and identities, we have finished the first four exercises from NCRT 9.1, 2, 3, and 4, which comprises of adding algebraic expressions, finding the difference between algebraic expressions, and finding their products. Product, we have different types. Multiplying a monomial by a monomial, monomial by a binomial, monomial by a trinomial, and how to find the product of two binomials, two trinomials. All this we saw under product of algebraic identities. So this is the concluding part of this chapter. The name of the chapter is Algebraic Expressions and Identities. So in today's class, we will see some algebraic identities and how they are used in expanding certain expressions. So this is what is done. Addition, subtraction, multiplication is done. This is covered in 9.1, 9.2, 9.3 and 9.4 of NCRT. Now today 9.5, which is of algebraic identities.
Excuse me, ma'am. This is Aishwarya. I just joined right now.
No, you have not missed anything. Don't worry. Don't worry. We're just about to begin. Yeah. So this is the first one, children. Now, how do you find the product of a plus b and a plus b? That is a plus b multiplied with itself. What is a plus b into a plus b? So this is a binomial. This one is the binomial. So we have to find the product of the binomials. Here it is a binomial multiplied with itself. The binomial a plus b multiplied with itself. So how do we multiply this? We multiply the first term a with the second bracket a plus b and the second term plus b with the second bracket a plus b. This is the first step, right?
Yes, ma'am.
We're trying to multiply the binomial a plus b with itself. We're trying to multiply the binomial a plus b with itself. Okay, so for that, we need to write the first term of the first bracket multiplied with the second bracket, the second term in the first bracket multiplied with all the terms in the second bracket. Now this is equal to a into a square, a into a square, a into b, ab, b into a, ba or ab, b into b, b square. So now plus ab plus 1ab plus 1ab is 1 plus 1, 2 plus 2ab. You're not multiplying, addition. So a square plus 2ab plus b square. So this is an algebraic identity. A plus b the whole square. Why a plus b the whole square? Because a plus b into a plus b. Like x into x is x square. A into a is a square. Similarly, a plus b into a plus b is a plus b the whole square. A plus b into a plus b is a plus b the whole square. So a plus b the whole square is equal to a square plus 2ab plus b square. Now this is an algebraic identity. A plus b the whole square is equal to a square plus 2ab plus b square. All right? All right, children? Yeah, please acknowledge. Online students.
Again, ma'am.
So write down this quickly. Give the heading algebraic identities. Give the heading algebraic identities and write down this, children.
Ma'am, I'm not done with the exercise. So should I continue and write this? Or?
No. Give the heading algebraic identities and write down this, and then you can work the sums from the exercises. Exercise.
Done, ma'am.
Yeah. All right. The next identity.
Ma'am, can you show that just for a minute? I'll just take a picture.
Yeah, 1 second. One second. Sorry, children, just a second. Yeah. Yeah, Aishwarya, you wanted it, so do it again. Write down fast. The next one is a minus b into a minus b. So it is a into the second bracket a minus b into the second bracket a minus b. A into a square minus ab minus ba or ab plus b square, which is a square minus 2ab plus b square. So a minus b the whole square is equal to a square minus 2ab plus b square. Done, children? Okay, so the next one is a minus b into a plus b or a plus b into a minus b. So how do we multiply this? The first term a with the second bracket a minus b. The second term b plus b with the second bracket a minus b. All right. Now a into a squared. A into minus b. That is plus a. It is a meaning plus a it is. So a plus a into minus b. So plus into minus minus. A into b, ab. So it's minus ab here. I've told you multiply the signs when you're multiplying two terms. When you're multiplying two terms, first multiply their signs. Then if they have any numerical part, okay, some numbers involved, multiply the numbers, then multiply the letters. See now, if you have minus 7ab into minus 5, whatever, like b square c. So first multiply the signs, minus into minus plus. Then multiply the numbers, 7 5s are 35. Then the letters a, b into b square is b cubed because the power is 1 here. 1 plus 2, 3. When bases are same and it's multiplication, we add the powers 1 plus 2, 3 and c. Multiply the signs, multiply the numbers, multiply the letters. Then plus b into plus a. Plus b into plus a. So plus into plus plus a into b, ab. Then plus b into minus b. Plus b into minus b. Plus into minus minus b into b, b square. B plus b. B plus b is 1b plus 1b. 1 plus 1, 2, 2b. B into b. Bases are same and it's multiplication. Add the powers. 1 plus 1, 2. What is 2 b square c square plus 3 b square c square? B square c square will come down as it is. Because when you're adding or subtracting like terms, b square c square as it is. 2 plus 3, 5. See, supposing you have 2 b square c square, 3 b square c square, 4 b square c square, 5 b square c square. They're all like terms. And if you have to add them, B square C square as it is. 2 plus 3, 5. 5 plus 4, 9. 9 plus 5, 14. This is the answer. On the other hand, if you have to multiply them, okay, you have to find the product. 2b square c square into 3b square c square into 4b square c square into 5b square c square. Then the product will be 2 into 3, 6. 6 fours are 24. 24 into 5, 120. Then b square into b square into b square into b square. Bases are same, multiplication, add the powers. 2 plus 2 plus 2 plus 2, 8. B to the power 8. Then c square into c square into c square into c square. Bases are same, multiplication, add the powers. 2, 2, 2, 2, 8. This is the answer for the product. This is the answer for the product. But if you're adding or subtracting like terms, the literal, that is the letters, they'll come down as they are. We will not manipulate the letters there. That will just come down as it is. Even if you're adding 100 like terms, that b square c square will come down as it is. Only the numerical coefficients are calculated. While adding or subtracting, the letters, addition, subtraction can be performed only on like terms. So if they are like terms, if there are some 1000 like terms, 1000 b square c square terms are there. So the answer will be b square c square only. Only that number will change. The number before b square and c square will change. And what will be that number? It will be you'll have to total the coefficients, the numerical parts in all the terms. That's all. But if it's multiplication, you should multiply the signs, multiply the numbers, multiply all the b squares, multiply all the c squares. So you will get b raised to some huge power, c raised to some huge power. So here, when you find the product, so when you multiply a plus b and a minus b, okay, so then after this, minus ab plus ab gets cancelled. So we are left with the two terms a squared minus b squared. Therefore, a plus b into a minus b is a square minus b square. Or the other way, a square minus b square is a plus b into a minus b. Everything can be written the other way. See here also, you can say a square plus 2ab plus b square is equal to a plus b the whole square. Similarly, a square minus 2ab plus b square is equal to a minus b the whole square. So these are the three important algebraic identities. We have many more. For 8th standard, we have only these three. One more I'll tell you. 4 you have in all, sorry. All right. There are many algebraic identities, but for 8th standard, these 4. Now we have seen 3. I'll tell you one more. So you can tell it both the ways. It's a square plus 2ab plus b square is a plus b the whole square. A plus b the whole square is a square plus 2ab plus b square. Not to get confused, a plus b the whole square is a square plus b square. No, you can check that. If you feel, if you feel a plus b the whole square is a square plus b square. See, normally we tend to think like this. A plus b the whole square is a square plus b square. Just give some numbers. Now, supposing a is 1. Supposing a is 1 and b is 2. A is 1 and b is 2. Okay, what is a plus b? 1 plus 2. What is 1 plus 2? What is 1 plus 2 the whole square? 3 square, which is 9. On the other hand, you get 1 square plus 2 square, correct? And what is 1 square? 1. 2 square, 4. And what is 1 plus 4? 5. See, the two sides are not equal. If you say a plus b the whole square is equal to a square plus b square, then both the sides you must get the same answer. But you try this. A plus b the whole square is a square plus 2ab plus b square. Now here when a is 1 and b is 2, 1 plus 2 the whole square, 3 square, 9. Here, 1 square plus 2 into 1 into 2 plus 2 square, correct? A is 1, so 1 square plus 2 into A into B, 2 into 1 into 2 plus B square, 2 square. So what do you get? 1 square is 1 plus 2 into 2, 4. 4 into 1, 4 plus 2 square is 4. So 4 plus 4, 8 plus 1, 9. Yeah, here you get the same answer on both the sides. So A plus B the whole square is not A square plus B square, and A minus B the whole square is not A square minus B square. A plus B the whole square is equal to A square plus 2AB plus B square. A minus B the whole square is A square minus 2AB plus B square. Only the middle term 2AB will be plus minus. If it is A plus B the whole square, A square plus 2AB plus B square. If it is A minus B the whole square, it is A square minus 2AB plus B square only, plus B square. And the other one is A square minus B square is A plus B into A minus B. A square minus B square is A plus B into A minus B, or A plus B into A minus B is A square minus B square. Written all this? And finally, we have x plus a into x plus b. X plus a into x plus b. So how will we find this product? The first term x multiplied with the second bracket x plus b. The second term plus a multiplied with the second bracket x plus b. So x into x, x squared plus bx plus ax plus ab. X squared, bx, ax, ab. So x squared plus x is common. Between these two terms, x is common. So you just write one x here. So in the bracket, you will get a plus b. Let me write the a term first. Let me write the a term first. So x squared plus ax, I'll write ax and then the bx term plus ab. All right, so it is x squared plus x is common, no? Now in the bracket, you will have a plus b plus ab. See here, a into x, ax, b into x, bx. I've taken out this x common. So we have x plus a into x plus b. Once again. Yeah. So the identity is x plus a into x plus b is equal to x square plus a plus b of x plus ab. X square plus a plus b of x. That's how you read it. A plus b of x, meaning a plus b multiplied by x plus ab. Plus ab. Write down.
Done, ma'am.
Yeah. Done, children?
Yeah, ma'am.
Yeah.
Yes, ma'am.
All right. Yeah. So what do we have? Let's list the 4 identities we've just understood. Any order. Okay, any order. So the last one we did x plus a into x plus b is equal to x square plus a plus b of x plus ab. Then a minus b into a plus b or a plus b into a minus b is a square minus b square. This is also true. A square minus b square is a plus b into a minus b. See, it actually, the identities work like this. If the question is of this form, then the answer will be worked using this. If the question given is like this, then the answer will be worked like this. One side of the identity, an identity you see is an equation, right? It's an equation. We say a plus b into a minus b is equal to a square minus b square. You can see the equal to sign everywhere. So it's an equation. An identity is an equation. So it has 2 sides, the left hand side and the right hand side. If the question is like the LHS, then the RHS will tell you how to do the answer. If the question is like the RHS, then the LHS will tell you how to do the answer. So when you have to solve or work something using an identity, there cannot be a simpler question because using the identity, you can understand that the question is like this. So this is the way in which I should work the answer. It's like a map. If you know your destination, you just see the map and identify where you are standing and which route you have to take to go to your destination. So the identity has everything. Yeah, my question looks like this, so my answer should be work like this, provided you know the identity correctly. Yeah, then after this, a plus b, the whole square is equal to a square plus 2ab plus b square, and a minus b, the whole square is equal to a square minus 2ab plus b square. So we'll, in this exercise 9.5, we'll be working with these 4 identities. All right. And I heard that division is removed from your syllabus, but we will learn division also. Believe me, it is very important. It's very important. That's all I can say. It's very important. So we will also learn how to divide algebraic expressions, because I heard from a student that it's been deleted, but since it's very important, we will be doing it in the class sheet. Even for 9th, they've removed it. For 10th also. You don't mind that. No matter how much you know, it's not like a load, no? See, when you're when you have to lift a bag, which weighs 2 kgs, right? It's heavy. If I add 1 more kg to that bag, it becomes heavier. Another kg becomes more heavy. So when I keep increasing the weight, you're not able to, like hold it any longer because it's very heavy and it's out of your strength to hold it. But addition of knowledge to the memory is not like that. When you learn more and more, you don't feel heavy in your mind. No, oh, I can't hold more than this. Does your head become heavy? No. In fact, you become a better person. You feel more confident. It doesn't feel heavy. You just have to take the effort to remember it. That's all. Practice it a few times, and once it goes to memory, it stays there with you forever. And when you have to use it sometime in the future, and when your friends around you don't know, that feeling is going to be extremely awesome. Yeah. So nothing goes waste. And this division is very important. It's very easy as well. Yeah. Anyways, now we are not doing that. I think I can do it in today's class, but let's see. All right. Now having understood the idea, yeah, you can stop working, children. Yeah. You can wait here or you can go. Oh, something's come. Okay, yeah, then you can go. I can't see. Yeah. Bye. All right, children. So now see the question. Using a suitable identity, find. That means they're asking you to expand. Find means expand. Expand this one. See, if you're asked to find, if I say find, what will you do? What's the answer? Find. What's the answer?
9.
9. I say find. Find. What will you say?
25.
25. 25. I say find. Okay, I'll not make it. Okay, find. 13. In the same way, find. Yeah, so find this one means find 2x plus 3y the whole square. That means square it. Square this expression is the question. Square this expression is the question. Now to square this, we have to use an identity. So what's the identity? What's the identity that goes with this? It looks like a plus b the whole square, correct? The given question looks like a plus b the whole square, where your a is 2x and b is 3y. The given expression, that is a question, looks like a plus b the whole square, where a is 2x and b is 3y. And you can see the plus sign also there. So see 2x plus 3y the whole square goes with a plus b the whole square, where a is 2x plus b is 3y whole square. Yeah. Yeah, you can do. Yeah, your grandfather's come. You can leave. Yeah, Santosh, you're going by yourself, right? You can stop working. Yeah. Yes, darling. All if you wind up, yeah. Yeah. Okay, now how do we present the answer? All right. So 2x plus the given question is 3x, 2x plus quite. Children, quite. Okay, so this looks like a plus b the whole square, which expands to a square plus 2ab plus b square, correct? What is a here? 2x. And what's b? 3y. Okay. Yes, you. So if the question is a plus b the whole square, the answer is a square plus 2ab plus b square. But if the question is 2x plus 3y the whole square, then what will be the answer? Instead of a square, it will be 2x the whole square plus 2ab, 2 into 2x into 3y plus b square plus 3y the whole square. That is in the identity. In this identity, instead of a, you must use 2x. Yes. And instead of b, you must use 3y. This is the answer. The question looks like this. So this is the answer. What's the answer? A squared plus 2ab plus b squared is the answer. Yeah, Atmika, your mother's waiting. The question looks like this, children. So this is the answer. This is the answer. In the answer, in place of A, you must replace 2x. In place of B, 3y. And you get it. All right? Yes, yes. Yeah, children. So you need to first write the identity. Sorry. You need to first write the identity. A plus B, the whole square is equal to A squared plus 2ab plus B squared. First write the identity. And then where A is 2x and B is 3y. This is the first step. Now you write the given question. 2x plus 3y, the whole square is equal to the question. The question looks like this. So what's the answer? This is the answer. Instead of A, 2x, the whole square plus 2 into 2x into 3y plus 3y, the whole square. The mistake you can do is writing 3y like this. It's not like this. B should be squared. What is B? This is B. The whole of B should be squared. It is not just 3y square like this. Okay, so now 2x the whole square meaning 2x into 2x. 4x square. 2 into 2 is 4. X into x is x square. 2 into 4. 2 into 2, 4. 4 3s are 12. 12xy plus 9y square. All right. Is that fine, children? Online students?
Yes, ma'am.
So see the steps. Don't write now. See the steps. The first step is to identify the correct identity. That's the first step. And then you must write out the values or the terms or the expressions for A and B. A is 2x, B is 3y. Then you must write the given question, 2x plus 3y the whole square. And you know that the answer will be like this. Since the question looks like this, you know that the answer should be like this. So here A square, so 2x the whole square. 2ab, 2 into 2x into 3y. B square, B is 3y, so 3y the whole square and then expand that. That's all. Now the same thing can be numerical also. Now if you have to find 103 the whole square, okay, you should not do 103 into 103. This is 4th standard. Now 103 into 103, don't do like this. 3 3s are 9, 3 into 0 is 0, 3 1s are 3. Don't do it like this. You are expected to use a suitable identity to find the value of 103 the whole square or 103 squared. So 103 squared can be written as 103 can be written as 100 plus 3, correct? 103 can be written as 100 plus 3 and the square. Now this is of what form? A plus B, the whole square, correct? Where A is 100 and B is 3. So the question is like A plus B the whole square because 100 plus 3 the whole square. The question is like A plus B the whole square because 100 plus 3 the whole square. So what's the answer? A square plus 2ab plus B square is the answer. But instead of A, you should use 100. So 100 square plus 2 into A into B. 2 into 100 into 3 plus B square, 3 square. So 100 square is this one plus 600 plus 9. And add this and that's the result. So see here. Go through this one. No, not So first the identity. And 103 the whole square does not look like a plus b the whole square. So we should make it look like a plus b the whole square. See, 103 the whole square, does it look like a plus b the whole square? No. Then you make it look like that by writing 103 as 100 plus 3. So then it looks like a plus b the whole square, where a is 100 and b is 3. So now this 100 plus 3 the whole square is equal to a square plus 2ab plus b square. So the same thing we'll have to do for a minus b the whole square. Similar, just the identity is different, but the working is the same. Now let's do 4.9. 4.9 the whole square, or simply 4.9 squared. So now this 4.9 squared does not look like a plus b the whole square or a minus b the whole square. You should make it look like one of it. So 4.9 can be written as 5 minus 0.1. Now, if you don't know how to find that, how do you know it is 5 minus 0.1? I'll tell you something. So now 4.9 is close to 5, right? Okay, so 5. So subtract 5 and the given number, 4.9. Because, okay, let me start like this. 5 minus 2 is 3, right? Then what is 5 minus 3? 2. 5 minus 3 will be 2. Okay, so you think about it. So 4.9 is close to 5. So you write 5.0 and subtract the given number 4.9. What do you get? This becomes 4, this becomes 10. So 10 minus 9 is 1. 4 minus 4, 0, 0.1. So this means 5.0 minus 4.9 is 0.1. Also, 5.0 minus 0.1 will give you 4.9. Like 5 minus 3 is 2. 5 minus 2 is 3. So if you don't know 5 minus what will give you 4.9, then you subtract 5 and 4.9, you'll get a number, right? So 5 minus that number is 4.9. We know 4.9 is close to 5. So 5, subtract 5 and 4.9, we get 0.1. So if 5.0 minus 4.9 is 0.1, it also means 5.0 minus 0.1 will be 4.9. So that's how you can find. So 5.0 minus 4.9 is 0.1. So this means 5.0 minus 0.1 is 4.9. So 4.9 the whole square can be written as 5 minus 5.0 is 5. 0.1 the whole square. So we make it look like a plus b the whole square or a minus b the whole square. So here a minus b the whole square. You can also write it as 4 plus 0.9 the whole square. But we prefer this. This is not wrong. You can also do it like this. 4.9 can be written as 4 plus 0.9. Because 4.9 is 4 plus 0.9. Then that looks like a plus b the whole square. If you write it as 5 minus 0.1 the whole square, it is like a minus b the whole square. Anything is fine. But we prefer this. See, like if you have 99 squared, you know, writing that as 90 plus 9 the whole square and writing it as 100 minus 1 the whole square. This is preferred. Wherever the calculation is lesser, 99 is 90 plus 9, also 100 minus 1. Now, when you use 101, calculation becomes easy, you know, because 100 square, you just have to add 4 zeros. Wherever the numbers involved will lead to lesser calculation or quicker calculation, we prefer that. That's all. So we prefer 100 minus 1 the whole square over 90 plus 9 the whole square. Okay. So I said for 4.9 the whole square does not look like a plus b the whole square or a minus b the whole square. There's only one number. So you must split and write it as two numbers. So 4.9 is written as 5 minus 0.1. We are not changing the question. 5 minus 0.1 is 4.9 only. And that whole square. Now we have made the question look like a minus b the whole square. So the answer is a square minus 2ab plus b square. What is a? 5. What is b? 0.1. This you can do. Look at this one. This is how you present the answer. Identity. Make the question look like a minus b the whole square. Then write out the values of a and b. Then write this one. This is a minus b the whole square. No. So it is a square. You have the answer here. See, you have it here. How to write this step? If your question is how to write this step, this is only this step. A square, 5 square, minus 2ab, minus 2 into a, 5 into b, 0.1. Then see the sign is here, plus b square, 0.1 square. We just substitute. This is only the answer. We know that this is the answer because the question is like this. This is the question, which looks like a minus b the whole square. So this is the answer. I'm going to write this only here. Instead of a, I'm going to use 5. Instead of b, I'm going to use 0.1. That's all. This one is what is here.
Ma'am, I have a doubt.
Yeah. Yes, Shreya.
Ma'am, why is there 25 minus 1 plus 0.01, ma'am?
Okay, let's multiply 0.1 into 0.1, correct?
Yeah, ma'am.
Okay, so now what is 1 into 1? 1.
1.
And the product, in the product, after the decimal point, there should be 2 digits because 1 plus 1, 2 digits, not this number 1. After the decimal point, 1 digit here. Here also after the decimal point, 1 digit. So in the product, after the decimal point, 2 digits. So 2 digits, but we have
okay,
only 1. So 0.01. Okay, let's then understand this one.
Okay.
What is 0. Like say 3 into 0.15? So this is nothing but 15 threes are 45. This is nothing but 15 threes are 45.
0.045.
Yeah, here after the decimal point, 1 digit. Here after the decimal point, 2 digits. So totally 1 plus 2, 3. So in the product, after the decimal point, there should be 3 digits. But the product has only 2 digits. So it will be 0.045.
Okay, ma'am.
Yeah, 0.1 into 0.1 into 0.1 into 0.1 into 0.1. The product is 1 because 1 into 1 into 1 into 1 into 1 is 1 only. But after the decimal point, there should be 5 digits. After the decimal point, there should be 5 digits. But we have only 1 digit. So for the remaining, you should add zeros. So it will be 0. See here, 1, 2, 3, 4, 5 digits.
Okay, ma'am. Got it, ma'am.
Yeah, very good. So here also, see here, 2 5s are 10. 10 into 0.1. 10 into 0.1. So this is like 10 into 1, 10. 10 into 1, 10. Then after the decimal point, 1 digit. So after the decimal point, 1 digit. So it's 1. 1.0, which is 1. That's what you see here. 1.0, which is 1. See, I'll tell you this again. This one. 2 into 5 is 10. And 10 into 0.1. 10 into 0.1. 10 into 0.1. 1 is nothing but 10 into. Just remove the decimal point. It's like 0, 1, which is 1. So 10 into 1 is 10. After the decimal point, 1 digit. So here, 1 digit. 1.0, which is 1. Then 25 minus 1 is 24 plus 0.01. So 24.00, 0.01. Like this, you need to place the digits. Don't see it. It's not 24 and I don't know, like 0.01 like this and no. 24 means, see, I'm talking about this one. 25 minus 1 is 24, which is 24.00. And then 0.01. So 24.01. So when you actually multiply 4.9 with itself, this is what you will get, 24.01. So this is finding the value through an identity. Finding the value through an identity. And if the given question does not suit any identity, you must make it look like one of the 4 identities. Now look at this. So see, children, the first one is this is the first one, children. Example 11. So here we had to use a plus b the whole square, and for 2x plus 3y the whole square, a plus b the whole square, and for 103 square we have to write 103 as 100 plus 3 the whole square and treat it as a plus b the whole square and work it. Okay, so you can see one algebraic form and one numerical form. One algebraic expanding like 2x plus 3y the whole square, then the other one is numerical 103 the whole square. Then in this question, in example 12, that was example 11. In example 12, we have a minus b the whole square. That is 4p minus 3q the whole square. And we have 4.9 squared. 4.9 is 5 minus 0.1 the whole square. So you can work both using a minus b the whole square. That was example 12. Now example 13. In example 13, see the first term. See, this is, we'll see, don't look at them. Don't look at these two now. We're talking about this one. Online students, use the emoji. Raise your hand. Yeah, quickly. Aishwarya, Sai Smriti, Gayatri, Shriya. That's all. Harsha, Anantika, Lakshana, Saujanya. Okay, thank you, online students. Okay. Yeah, we're looking at the first one. Now there are 2 brackets. Okay, look at the first terms in both the brackets. Look at the first terms in both the brackets. 3 by 2m, 3 by 2m. They're the same. Look at the second terms in both the brackets. 2 by 3n, 2 by 3n. They're the same. And look at the connecting signs. Plus, minus. So, the product given here is of the form. See, okay, now see here. I'll also put 2 brackets, okay? I'll also put 2 brackets. Now, in the 2 brackets, the first terms are the same, no? So, A. The signs plus, minus. The second terms are also the same, no? So, B. So, the given question is of the form A plus B into A minus B. The given question is of the form A plus B into A minus B. So you must identify which form or which identity the question looks like. See, in the question there are 2 brackets. So even I'm using 2 empty brackets. Then we see that in the 2 brackets in the question, the first terms are the same. So I'm writing A. Same, no? So A. Then the signs plus, minus. Then the second terms are the same. So B. So the question is of the form A plus B into A minus B. So what's the answer? A square minus B square. This is the answer. This is the answer. But what is A? What is A? 3 by 2m. What is B? 2 by 3n. This is the answer for this question. For A, you must use 3 by 2m. For B, you must use 2 by 3n. And how will you work this? 3 by 2 into 3 by 2. 9 by 4. M into m square. Minus 2 by 3 into 2 by 3, 4 by 9, n square. This is the answer. That's all. Sorry? They're unlike terms, no? No, it's m square and n square. LCM where you're saying in the question itself, huh? After 9 by 4 m square. No, they're unlike terms. So you don't try to simplify them further at all. They're unlike. So you can just leave them like that. Yeah, so this is how you should present your answer. First, write the identity. The question looks like a plus b into a minus b. So the answer is a square minus b square. Where a is this one and b is this one. All right. Then coming to the given question, we have to find this product, right? So write that one. Write the given question. That is, the question looks like this, right? So what's the answer? A square minus b square. This is the answer. So see your answer here. A square minus b square. So 3 by 2 m the whole square, 2 by 3 n the whole square. See, please understand that we are writing this one using the identity. This is the identity where the question is like this. So the answer will be like this. This is the given question, which looks like a plus b into a minus b. So the answer is a square minus b square. But you should not write a square. What is a in the given question? This one. What is b in the given question? This one. And put the squares because a square minus b square. And then work that. What is 3 by 2 m the whole square? 3 by 2 m into 3 by 2 m. 3 by 2 m into 3 by 2 m. So 3 3s are 9, 2 2s are 4, m into m square. Now look at the numerical version. Now the question here looks like, see here, there's a number here. So let's call it a and the square. So square minus minus. There's a different number here, b square square. So it looks like a square minus b square. The question looks like a square minus b square. So the answer is a plus b into a minus b. The answer is a plus b into a minus b. Same thing, we're using it backwards because the question given is like this one. So then this will be the answer. I told you, you can use the identity forwards and backwards. So we have 983 square minus 17 square. Now this is some number. So let me call it a and there's a square. So square. There's a minus. So minus. A different number. So b and square square. So it's of the form a square minus b square. So the question is like this. This is not the answer. This is the question. What is the answer then? A plus b into a minus b is the answer. But what is a here? Because see here, the square and the square, you just do that in your mind. You're comparing. You're comparing 9 a square and 983 square. When you compare this, when you're comparing a square and 983 square, cancel the square and the square in your mind. So what is a? 983. So a is 983 plus b. See, cancel the square and square. So b is 17. So 983 plus 17 into 983 minus 17 is the answer. That's all. This is the answer. Should simplify this. So when you add, you get 1000 and it's into multiplication. When you subtract, I'm scared. What will you get? 16 and 8 minus 6. I think this is the product. I'm sorry, the difference. And this is the answer. All right. That's all. You can have a look at it.
Excuse me. We aren't supposed to write this session, right?
No, 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 no. No, I'm just pausing. I'm just waiting for you to have a look at the slide to understand the presentation.
Okay.
All right, children. Now, same example, there's a third subdivision. Here the given question is find this product 194 into 206. Yeah, so you will say A into B, but there's no identity like that, right? Okay, so now what is that number between 194 and 206? Now, this question is very vague. When I ask you what is that number between 194 and 206, is vague, but you can give the correct answer. Just tell me what is that between 194 and 206?
Mom, 200.
200. 200. So 194 can be written as 200 minus 6. And 206 can be written as 200 plus 6. So that number which lies between 194 and 206. So 194 can be written as 200 minus 6. And 206 can be written as 200 plus 6. Yeah. So you will understand why we are doing that. See, this is the given question. This is the given question. Or we are writing it in a different way. We see, you can write in a different way without changing the value of the numbers given. See, we are writing 194 only, but in a different way. 200 minus 6 into, we're writing 206, but in a different way. 200 plus 6. So we have managed to write the product in the form. See here, there are two brackets. There are two brackets wherein the first terms are the same. AA. The second terms are also the same. BB. And the connecting signs minus and plus. So we have made the given question look like A minus B into A plus B. This is not the answer. We are still working with the question only. We have not answered the question. The given question does not suit any identity. It looks like A into B, as some of you told me. It doesn't suit and it doesn't go with any identity. So you make it look like the LHS or the RHS of any identity. This part is understood. So when you compare, it looks like A minus B into A plus B. So now you can go ahead like this. So the given question looks like A minus B into A plus B. So the answer is A square minus B square. Because the given question is of the form A minus B into A plus B, the answer is A square minus B square. Now what is A? 200. See, this is A, this is A, this is B. So 200 squared minus 6 squared. So 200 square meaning 2 into 2, 4, followed by 4 zeros. Because 200 into 200 minus 36, and the difference is the answer. That's the answer. See, you can write the identity both the ways. No, you can write it as A square minus B square is equal to A plus B into A minus B also. But you will always see that I write it in this form. What I write first is the question. Then I write the answer. So you write it in the correct way, meaning the order. The left-hand side, let it be the question. And the right-hand side, the answer. So I have written the question in the left-hand side. Though this one does not directly look like A minus B into A plus B, we know that we are going to make it look like that. So this is we are going to make the question look like this, for which this is the answer. So see here, we made it look like 200 minus 6 into 200 plus 6. So 200 minus 6 into 200 plus 6, A minus B into A plus B. Answer is A square minus B square. 200 square minus 6 square. So what I've written here is See, this difference is this one. What you see here is this the given question, no? I've just put that back. I just put the question back, that's all. See, 200 minus 6 is 194, 200 plus 6 is 206. I've just put the question back. The answer for this question is this one. Online students? Any questions still here?
No.
No, ma'am.
Okay. Now look at this one. So now, if I ask you what is between 501 and 502, you'll be like 500.5, 501.5.
Ma'am,
So-
we selected 500 itself, ma'am.
Yeah. So this question should be written using the number 500. Using the number 500. Now 501 into 502 can be written using the number 500. So 501 can be written as 500 plus 1 and 502 can be written as 500 plus 2. Making it look like x plus a into x plus b. 1 minute. I was too fast in saying that. 1 minute. Okay, so we have two brackets. We have two brackets where the first terms are the same. So x, x. The second terms are different. So a, b. And the connecting sign plus, plus. So we have rewritten the question to look like x plus a into x plus b, which can be worked as x squared plus a plus b of x plus a. You haven't still memorized the identity. So once you memorize, it will be good. Now you can just refer, go back and see and write. No. I'm just saying, but by the next class, you should have memorized identities. I'll come again. So 501 into 502. Now this one does not go with any identity directly. It's like A into B. So what we do, we use the number 500 and we write 501 as 500 plus 1 into 502 as 500 plus 2. This is the first step. Now we have two brackets where the first terms are the same. So x plus the second terms are different. So a and b. So the given question is of the form x plus a into x plus b, which should be worked as x squared plus a plus b of x plus ab, where x is 500, correct? Where x is 500, what is a? Online students, what is the value of a? 1. And what's the value of b?
2.
2. Yeah, 2. So it will be 500 squared plus a plus b, 1 plus 2 of x. Don't write x, 500 plus ab, 1 into 2. So 5 square is 25 followed by 4 zeros plus 1 plus 2 is 3, 3 into 500. 1 plus 2 is 3, 3 into 500 is this one plus 1 into 2, 2. Find the sum. The next one is 95 into 3. 95 into 103. Now you can rewrite 95 and 103 using the numbers 100, using the number 100 because 100 comes not exactly but in the middle, but it's between. I'm saying between meaning it comes between 95 and 103. It's not equidistant, but it comes between 95 and 103. So you rewrite the numbers using 100. 95 can be written as 100 minus 5. 103 can be written as 100 plus 3. Making it look like 100 plus of minus once again. Because it doesn't go with the identity, you need to make.
Ma'am, may I be excused for a couple of minutes?
Okay. Understood what I've written? I made it look like x plus a into x plus b. I've made it look like x plus a into x plus b because it was like x minus a into x plus b. Why I'm saying x? Because look at the brackets, look at the bracket. The first terms are the same. X, x. The second terms are different. So a, b. The connecting sign should be plus. Actually, it is x plus a into x plus b. We don't have x minus a and x plus b. So you write 100 minus 5 as 100 plus of minus 5. Because plus into minus is minus. So now x is 100, a is minus 5, and b is 3. All right. Tell me. 95 into 103 is equal to 100 minus 5 into 100 plus 3. So this can be, this step you don't have to show actually, you can just do it in your mind. See, I'll tell you, you don't have to even show that because now this is in the form, you write like it's in the form x plus a into x plus b. Where x is 100, where x is 100, plus b is plus 3. So b is 3. Here plus a is minus 5. Plus a is equal to minus 5. So a is equal to minus 5, no? It is, so a is minus 5. You don't have to show that step. You can directly, because it is x plus a, but here it is minus 5. So a is minus 5. A is minus 5. If it is plus 5, then a is 5. Because it's minus 5, plus a is minus 5. So a is equal to minus 5. If you're not comfortable, then you should give the step. If you feel, no, I'm not able to get that clearly, then you have to go with one more step. You write it as 100 plus minus 5 in the bracket. So where x is 100 plus a, this is a, x plus b, b is 3. So a is minus 5, b is 3. Then you'll have to put it in the formula. Yeah. So when you are working, you can give that step extra if you want. If it's not clear, you can just do the step extra. Plus minus 5. So on comparing, you get a is 100, x is 100. See here. This is x plus a, no? This is x plus a. This is x plus b. You're comparing it with x plus a and x plus b. X is 100, a is minus 5, b is 3. So what's the answer? The question looks like this. So this is the answer. What's the answer? 100, sorry, x square. This one square. Plus a plus b of x. So plus a plus b, right? A. This one. See, this is a. Plus b of x. That means you should multiply. This is a plus b into x. This bracket is just for you to be careful while calculating. Otherwise, you can remove this bracket. See, this is a plus b into x. Plus a into b. This is a, this is b. Yeah, then you'll have to simplify. Minus 5 plus 3. Minus 5 plus 3.
If I take it.
Somebody's mic is enabled. Disable your mic. Yeah, so 100 square is here. And here minus 5 plus 3. What is minus 5 plus 3? Minus 2 into 100. Minus 200. And then minus 15. Simplify and is that fine?
Yes, ma'am.
Okay. So we have seen the applications of all the 4 identities. A plus b the whole square, a minus b the whole square, a square minus b square, and x plus a into x plus b. So if you understand these 4 examples clearly, then if there's any slight difference in the questions which are of this form, you can understand them. For that, these 4 examples must be very clear to you. Work on these 4 examples. If these 4 examples are very clear to you, then the exercise is clear. If there's any variation in the question also, you will understand. Maybe not by yourself, but once we discuss in the class, it will be okay for you. These 4 examples are important because this one covers all the identities, both expression as well as the numerical version. Like expand 2x minus 3y the whole square. Also some number also, like expand 105 square or find the value of 105 square. So we have seen both the algebraic and the numerical versions. So now by the class on Wednesday, I'll share these images with you. Work out this in your notebook. I'll share these images. Today, anyways, you cannot do it. So tomorrow, by tomorrow morning, I'll share the images with you. Complete this in your tuition notebook before the class on Wednesday. Wednesday's class, example 11, 12, 13, 14 must be in your notebook, not on your device. From there, it should come to your notebook. All right. Okay, I'll just give you 5 minutes to relax or refresh. So online students have the option to stretch, relax. You can also do that. I'll just come back in 5 minutes, children. I'm not taking a break. Before I teach you division, I just want you to take a break. I'll just come back in 5 minutes. Online students, I'm back. Yeah. So see the questions here. Divide. I'm just reading the questions. Divide. You can see three terms here by a single term. So meaning divide this trinomial by this monomial. Here we have three terms by a single term. Again, a trinomial. Divide this trinomial by this monomial. Here again, three terms by the single term. See, you can even have two terms divided by a single term. See, you can divide a binomial by a monomial, trinomial by a monomial, quadrinomial by a monomial, that is four terms. Quadrinomial by a monomial. See, the numerator can be any number of terms. The numerator can have two terms, three terms, four terms, five terms, any number of terms divided by a single term. Divided by a single term. Like in the first question, it is divided by 3m square. Here, in the first question, in the first one, we have 9m to the power 5 plus 12m to the power 4 minus 6m squared divided by 3m squared. I'm saying you can have more terms also here. You can have more terms also here. You can have two terms, three terms, four terms, five terms, six terms, any number of terms in the numerator, but divided by a single term in the denominator, that is a monomial. So this is division by a monomial. This question is, the first question is division by a monomial. The second one also by a single term, by a monomial. The third one is also a single term, monomial. When you're dividing by a monomial, we will not use a long division method. But when it is not a monomial, that is if it's a binomial or a trinomial, see this is a trinomial. You're dividing by x plus 3, which is a binomial. You're dividing by 7x minus 1 plus 2x squared, which is a trinomial. So when you're dividing by a single term, no long division. If you have to divide by an expression which has more than one term, that is a binomial or a trinomial, it is long division. That's the difference. Correct? If you're dividing by a single term, numerator can have any number of terms, but divided by a single term, we won't use long division. If it is again any number of terms in the numerator divided by a binomial or a trinomial, then it is long division. So now here it's monomial. So how do you divide this? It's very simple. Here, the question is this one. This is the question. This is the dividend. This is the dividend. And this is the divisor. This is the divisor. So this can be written as divide the first term by 3m squared plus the second term by 3m squared minus the third term by 3m squared. That's all. Finished. Division is over. Divide every term in the numerator by the denominator. And the connecting signs, whatever is here, plus means the connecting sign is plus, minus, minus. Divide every term in the numerator by the denominator. This is understood. Now, 3 ones are 3 threes are. So you'll have 3 here. And then m to the power 5 divided by m to the power 2. When bases are same and it's division, we subtract the powers. So m to the power 5 minus 2. Correct. So m to the power 3. So 3m to the power 3. 3m to the power 3. Plus 3 ones are 3 fours are. So 4. M to the power 4 divided by m square. Bases are same. Division. So subtract the powers. Minus 2 m square by m square. Like they get cancelled. they get cancelled, or using the law 2 minus 2. M to the power 0. Anything to the power 0 is 1. Law of exponents. Anything to the power 0 is 1. This is the answer. This is the quotient. On performing the division, this is the quotient. The remainder is 0. This is the quotient. That's all. Understand this?
Yes, ma'am.
Okay. Now let's do the second one. So it will be 4z cubed divided by minus half z plus 6z square divided by minus half z. That is z, children. That's z. See, this is z. This is not 2. This is z. Then minus z divided by minus half z. Can we see that, all of you? We're doing this one. This is z, children. This is z. This is z. So since it's division by a monomial, it is not long division. We divide every term in the dividend by the divisor. So 4z cubed divided by minus half z. You understand this, right? Okay. Now we'll have to divide the numbers and then the letters. So first let's divide 4 by minus half, correct? 4 divided by minus half, correct? 4 divided by minus half. So 4 division becomes multiplication, reciprocal. So 1 by 2 becomes what's answer? Minus 8. Adha number வந்து அதான் வரும் minus 8. இப்போ the letters simplify பண்ணும். Z cubed by Z. That means bases are same, division, subtract the power. Z means Z to the power 1. So 3 minus 1. Z square. So this is minus 8 Z square. Plus. Sorry. Minus, plus into minus, minus. Sorry, see, not plus into minus, sorry. Plus divided by minus is minus. The rules for multiplication and division both are the same. What is plus into minus? Minus. Plus divided by minus is also minus. Rules are the same for multiplication and division. So here we have a plus sign, but here we have a minus sign. So plus divided by minus is minus only. Now we'll have to divide 6 and half. 6 divided by half, meaning 6 into 2 by 1, which is 2, 12. So 12. Then Z square by Z. So Z to the power 2 minus 1. Z. Minus divided by minus. Plus. Actually, Z and Z gets cancelled, no? Can we do that? Z and Z will get cancelled. Z in the numerator, Z in the denominator. Like 5 in the numerator, 5 in the denominator. Gets cancelled. Now we need to divide 1 by half. There's 1 in the numerator. There is nothing means there's 1 in the numerator. Divided by half in the denominator. So 1 into 2 by 1 or 2, which is 2. That's all. So simplify the numbers separately and the letters separately. That's all. So if supposing the numerator is a fraction, see, supposing in the numerator also you have like something like 4 by 3. Denominator you have some 2 by 6 or 2 by 7, like divided by 2 by 7. Nothing, just write 4 by 3 into 7 by 2. 2 ones are 2 twos are. So it will be 14 by 3. So you will get 14 by 3. That's all. And then the letters Z to the power whatever. Work the numbers in the rough column. Divide the numbers in the rough column. So convert the division to multiplication and take the reciprocal and simplify. So sometimes you will get a number like 2, 3, 4, something like that. Or you might even get a fraction. It's okay, just put that fraction here and then simplify the letters. And put it, that's it. The third one, it is 6x to the power 4 yz divided by 2xyz minus 3x cubed y cubed z divided by 2xyz plus 8. I'll just write it in the order, okay? So let me write x squared first, then y, then z to the power 4 divided by 2xyz. So the answer is 6 by 2 is 3. X to the power 4 divided by x. 4 minus 1, 3. X to the power 3. Y and y gets cancelled, z and z gets cancelled. Minus 3 by 2 is 3 by 2 only. 3 by 2 is 3 by 2. Z and z gets cancelled. X square, y square. Very good. X square, y square. In the numerator. You can put the 2 in the middle also like this. Plus 2 ones are 2 fours are. X square by x. X. Then y and y gets cancelled. 4 minus 1, 3. Very good. Send z cube. That's all. Clear, online students?
Clear, ma'am.
Yes, ma'am.
Very good. All right. Now let's understand how to divide an expression by a binomial. Yeah. So when it's binomial, it is long division. So place the divisor here. The divisor is x plus 3, children. I'm working this one. I'm working this. I'm working this one. The divisor is x plus 3 and the dividend is 2x to the power 4 plus 8x cubed plus 7x squared plus 4x plus 3. This is the question, children. All right? Okay. Now, listen very carefully. I just want to share something at this point. Online students, lower your hands. Aishwarya, Anantika, and Lakshana, lower your hands. Yeah, now online students, use the emoji, raise your hand. Gayatri, Aishwarya, Lakshana, Sai Smriti, Harsha, Shriya, Anantika. Okay. Thank you, children. Very good. Yeah, no, I was trying to say this. So long back, there was this, this is some many years ago. Sorry, once again. So there was a student. So my academic background is I'm a commerce graduate. Okay. So meaning I've completed my BCom. After that, I knew I'm not going to take up a job because I was very passionate about teaching. I was raised in a joint family. So I had my younger cousins in my house. So I used to teach them every now and then. And that's how I realized that I was interested or inclined towards teaching. And I just wanted to have a degree. I studied because I just wanted to have a degree, not because, yeah, it was like that. And I settled down with teaching ever since 1997. Okay. I finished my BCom in the year 1997. And since then I've been teaching. I used to teach my cousins at home, and that's how my, I started my journey of teaching. Now, so I'm not, like I don't have a professional degree. I am not a science student, meaning I have not studied science beyond 10th standard. So my subjects were different, correct? So if you know, commerce is all about accountancy, statistics, economics, business administration and stuff like that. So maths has been a part of my life till 12th standard. I had maths in commerce also. We had a special combination like that. So I learned maths till 12th standard. So then after, so science, I know science only till 10th standard. Beyond that, I don't know. Now, there was students who came to me like many years, some 10 years ago. There was this guy who came up to me after he finished his engineering to enroll his cousin who was in 8th standard. He finished his engineering and he came to me to enroll his cousin who was in 8th standard at that time. And this is what he told me. See, I don't know about engineering courses or engineering subjects. I don't know because I'm, now I just told you my qualifications. I don't know. But this guy told me that when you used to teach us in 8th, 9th and 10th, and when you went beyond our subject, meaning beyond what we learned in school, I thought you were just wasting our time. So I was not paying so much of interest or attention to the extra things which you taught us in the class. But I realized my mistake when I entered when I chose to do engineering, and mathematics there is all about what we learn in school. And he told his cousin to take as much as efforts as possible. See, if you want to pursue science, if you want to pursue science as your academics beyond 10th standard, then yes, it means if you are going to drop if you're not going to take up science beyond 10, then maybe this doesn't mean a lot to you. But this guy told me that since he did not focus much on mathematics during the school days, he had a tough time in engineering maths. And today I see that my daughter, she's now doing her BTech in biotechnology. And ironically, she's not passionate about mathematics and I did not force her. So she did not take maths in 11th and 12th because she's not so fond of mathematics. And yeah, and now so she has mathematics in BTech, her first semester, which is for the non-math students. That is, students who have not studied mathematics in 11th and 12th, studying simpler mathematics in the first semester. Students who have studied mathematics in their 11th and 12th will have a different math in their BE or BTech courses. So now the mathematics which my daughter is doing is all about this division and that portions which she has now for her first semester is all about school math. If you were good with mathematics, the algebra part of 8, 9 and 10, it's cakewalk. That's the fact. So school mathematics is the foundation. If you learn this properly with all these questions, why not, what about that way, this way, you must be very curious to know things. If you do that now, you will be blessed later. Your efforts will pay you off later. Now if you're like, this is not there in my syllabus, my teacher did not teach this lady is simply wasting our time. If you take it that way, see, this one is a fact because the student shared that with me. He made this mistake of not focusing on the details of mathematics, and he said he had a tough time in engineering. And now I see my daughter working on mathematics. So it's an extension. It's not exactly school math. I'm not saying it's exactly the school math and this division, but it's based on the principles of division which we learn here. Everything, exponents, everything. So pay attention, children. I'm not here to waste your time. I can just ignore this. No, it's not now. This is deleted from your portions for this year, so leave it. No. But I know it is important in the future. Now in engineering, they will not be concerned if this portion was deleted in your 8th, 9th, 10th, right? They'll only mention that you've already learned this in school. It happened in 11th standard also. During COVID, some portions were deleted, and when my daughter was in 11th standard, the teacher said this you've already learned in 10th, but in 10th it was deleted. That portion was not there. So you don't bother about the deleted portions. All this will be useful sometime in future. Going back to the division. So you need to place the divisor and the dividend like this. Yeah. 2x to the power 4, 8x cubed, 7x squared, 4x, 3x plus 3. Yeah. All right. Now, we need to get the first. See, that's how this is how we get started with division, right? So if you have like 85 divided by 3, you will have to start off from this place, right? 3 2s are 6. So you get started with this one, right? So similarly here, you need to identify the first term in the quotient. See, this is the quotient, right? This is the quotient, correct? So you start off with the quotient, right? You write 3 2s are 6. So you start off here. In the same way here also, you need to start off with the quotient. You need to identify the first term of the quotient. What will be the first term of the quotient? See, what you get here is a quotient. And then finally, what you get here is a remainder. So when you're dividing numbers also, you start off with the quotient. You place the digit 2 here. 3 2s are 6. Then 2 remains. 5 comes down. Again, you go back to the quotient. 3 8s are 24. 1 is a remainder. In the same way here, the first step is to identify the first term of the quotient. And how do you get that? Divide the first term of the dividend by the first term of the divisor. Before that, make sure that the terms are arranged in the descending order of the powers of x. See, supposing the dividend is 2x to the power 4 plus 4x plus 8x cubed plus 3 plus 7x squared. See here, x power 4, x cubed, then constant and x squared. Then the terms are not arranged in the descending order of the powers. So do that rearrangement. You should not write the terms like this. Then you'll go wrong with the division. That's the first step. So see here, x to the power 4, x to the power 3, x to the power 2, x and constant. See, it's okay if one term is missing also. Like, I hope all of us are listening. It's okay if you don't have a particular term in the middle. Like, for example, if you have 3x to the power 7 minus 5x to the power 5 plus 3x squared minus 11. That's fine. After 7, see, descending order, 7, 5, 2, constant. That's fine. It's okay if power 6 is missing, power 4 is missing. That is okay. With the given terms, the x's are arranged in the descending order of the powers. Power 7, then 5, then 2, and then the constant. The constant should be the last term. Similarly, the divisor. Divisor also, if you have 3 plus x, supposing in the divisor, it was 3 plus x. You must write it as x plus 3 because the constant should be placed in the end. 3, that constant should be in the end. If it is 3 plus x, don't write it as 3 plus x, x plus 3. If you don't do this arrangement, you will not do the division correctly. You will be able to do something, but not the correct word. You will not get the correct answer. So this is the first step. Checking if the terms are arranged in the descending order of the powers of x is the first step. Okay. So then get started with the quotient. To get the first term in the quotient, divide this by this. That is, divide the first term of the dividend by the first term of the divisor. What do you get? 2x cubed. 2x cubed. Correct? Now place that here. 2x cubed. Place that here. Now multiply 2x cubed with x and write the product here. Multiply after placing x cubed in the quotient, multiply x cubed with x. What do you get? What is x cubed into x? X to the power 4. Then multiply x cubed with plus 3 x cubed. You must multiply that term which you have placed in the quotient with everything here in the divisor. X cubed into x to the power 4. X cubed into plus 3 x cubed. That's what we actually do. Okay, let me not go back there again. All right, this is the first step, children. Okay, now change the signs because division is about subtracting. Division is about subtracting. Multiplication. See, here also when you 3 2s are 6. What did you do? 8 plus 6 you do or 8 minus 6? 8 minus 6. You are actually subtracting. There's a plus. The 6 is a plus 6. But you are performing 8 minus 6. You are actually subtracting 2. 5 comes down. 8 is a 24. 25 and 24 is 49. But you're subtracting. You're taking a minus sign. 25 minus 24. 1. So division is about subtraction. Okay, so you'll have to change the signs. Plus x to the power 4 becomes minus x to the power 4. Plus 3x cubed becomes minus 3x cubed. Change the signs throughout in the base. Okay, in the bottom row. Change the signs. Now simplify. Oh my God. 2, I forgot to write 2, children. Oh my God. 2x cubed. I wrote only x cubed here. I'm so sorry. It's 2x cubed, no? I wrote only x cubed. I'm so sorry. So 2x cubed into x, 2x to the power 4, 2x cubed into 3 plus 6x cubed. Change the signs. It's 2x cubed, children. I forgot. I wrote, meaning by mistake, I wrote only x cubed. All right. Yeah. So now I've corrected it. 2x cubed and multiply 2x cubed with x and 2x cubed with 3. Change the signs. Plus 2x to the power 4 minus 2x to the power 4 gets cancelled. 8x cubed minus 6x cubed. Take the new sign. Forget the old sign. Take the new sign. 8x cubed minus 6x cubed. Like terms. So x cubed will come as it is. 8 minus 2. I'm sorry, 8 minus 6, 2. So 2x cubed. Then you can bring all the terms also down if you want. You can bring all the terms down. Bring all the terms down. All right. Now repeat this step. Repeat this step. Divide the first. This is called the new dividend. This is called the new dividend. New dividend. Divide the first term of the new dividend with the first term of the divisor. Always this will be, meaning always you will divide by x. Always you will divide by x. Divide the first term of the new dividend by the first term of the divisor, which means 2x cubed divided by x. That is 2x squared plus 2x squared. Place that in the quotient. Place that in the quotient. All right. Now multiply plus 2x squared with x in 3. Multiply plus 2x squared with x in 3. What is plus 2x squared into x? Plus 2x cubed, because x squared into x is 2 plus 1. Add the powers, 3. 2x cubed. Then 2x squared into 3. See, you'll have to multiply 2x squared with x, 2x squared with 3. So it'll be plus 6x squared. Correct? Again, change the signs. Minus, minus. Cancels. 7x squared minus 6x squared. X squared. 7 minus 6 is 1. 7 minus 6 is 1. 1x squared or simply x squared. Now bring the terms which are not used down. Plus 4x plus 3 down. Now this is again called the new dividend. A new dividend. This is a new dividend. Divide the first term of the new dividend by the first term of the divisor, which means x squared by x, which is x. Place it here in the quotient. Place that here in the quotient. Now again multiply x with the terms in the divisor. That is x into x, x squared, and x into plus 3, plus 3x. Change the signs. Change the signs. Plus becomes minus, plus becomes minus. Plus x square minus x square gets cancelled. 4x minus 3x is x. And this one comes down. That's not used, so it comes down. Now again, this is called the new dividend. X plus 3 is the new dividend. Divide the first term. Divide the first term of the new dividend by the first term of the quotient x. See here, everywhere we are dividing by x only. Everywhere it is divided by x only. Only the numerator changes. First, the numerator is 2x to the power 4. Look at the board, Ariston. Then the term is 2. Then you divide by 2. Then you divide 2x cubed by x. Then x squared by x and then x by x. See these. First it is 2x to the power 4 by x. Then it is 2x cubed by x. Then it is x squared by x. Now what is x by x? X by x is 1. Plus 1. Plus 1. Again, multiply this with x plus 3. So 1 into x is x. And 1 into 3 is 3. Change the signs. 0. So which means the divisor is a factor of the dividend because remainder is 0, no? The divisor is a factor of the dividend or the dividend is a multiple of the divisor. See, when you're able to divide exactly 7 and 56, 7 8s are 56, 0 is a remainder. So what do we conclude? 56 is a multiple of 7 or 7 is a factor of 56. When the remainder is 0. If the remainder is not 0, then you cannot say these two statements. Since the remainder on division is 0, we say that 56 is a multiple of 7 or 7 is a factor of 56. Using the same thing here, since the remainder is 0, x plus 3 is a factor of the dividend 2x to the power 4 plus 8x cubed and so on. Or the dividend 2x to the power 4 plus 8x cubed, the dividend is a multiple of the divisor x plus 3. Got that, children? Online students?
Yes, ma'am.
All right. Okay. The second one I'll do it in the next class. I'll do the last one now. X cubed minus y cubed by x minus y. We'll wind up today's session with this one. Okay. Next is we'll divide x cubed minus y cubed by x minus y. By x minus y. All right. This is a little different. Arison, you are already distracted. Why you want to go home? You're hungry? There's something in your eye. Oh. You want to wash your eyes and come back? Who's coming? Okay, so here we have to divide x cubed minus y cubed by x minus y. Yeah, I want answers from you, children. So first step is to divide x cubed by x. What's the result? What is x cubed by x? Division, subtract the powers.
X squared.
X squared. X squared. So that will be the first term in the quotient, x squared. Next, what should you do? Multiply x squared with x minus y. So what is x squared into x? What is x square into x? X cubed. Then what is x square into minus y? X square into minus y. Yeah, online. Minus x square y. Minus x square y. Correct? Okay, so we're done with the multiplication. Yes or no? We're done with the multiplication. Okay, now time to change the signs. Change the signs. Plus becomes minus, minus becomes plus. Minus becomes plus. Opposite sign. Now, plus x cube minus x cube gets cancelled. The 0. Now, these two are not like terms, children. So you cannot simplify them. They're not like terms. So you'll have to bring them down as they are. They're not like terms, so you'll have to bring them down as they are. Now, which one to write first? Since you're dividing by x minus y, where x is the first term, you must write the term that has x first. So write x square y first, followed by minus y cubed. Because you're dividing by x minus y, where we have x first. So the term which has x will come first. Now repeat. X square y divided by x, correct, is equal to x square by x is x, y. So plus xy, plus xy. Now multiply plus xy with x. Multiply plus xy with this x. So xy into x is x square y. X square y. Then multiply xy with minus y. So plus into minus minus xy into y. Xy square. Xy square. Change the signs. Change the signs. Cancels. Again, they are not like terms. You'll have to bring them down as they are. But who will come first? Yeah, xy squared first, minus y cubed. Next. Next. By x. So what's the result?
Y square.
Y square. X and x will get cancelled, so y square. So plus y square, correct? Plus y square. Yes or no? Plus y square. All right. So now multiply this plus y square with the terms here in the divisor. Y square into x. X y square. X y square. Then minus y into plus y square. Minus y into plus y square. Plus into minus minus. Y square into y is y cubed. Because 2 plus 1, 3. So it will be what? Minus y cubed. Change the signs. Plus becomes minus. Minus becomes plus. Xy plus xy square minus xy square. Minus y cube plus y cube. All right. All right, children. That's it. So what do you conclude? What do you conclude? X cubed minus y cubed is a multiple of x minus y because remainder is 0. X cubed minus y cubed is a multiple of x minus y, and x minus y is a factor of x cubed minus y cubed. And using the division algorithm, what is the division algorithm? Dividend is equal to divisor into quotient plus the remainder. Fourth standard. Dividend is equal to divisor into quotient plus the remainder. Yes or no? Which is the dividend? X cube minus y cube is equal to divisor into quotient plus the remainder 0. So ignore it. This is an identity which you will see next year. This one is an algebraic identity. I told you, when we started today, I said we have many more identities which we'll see next year. This is one of the other identities, algebraic identities. X cubed minus y cubed is equal to x minus y into x squared plus xy plus y squared. All right. In some schools, if at all you learn division, they'll add x cube, then plus some 0x square. I don't do all that. For the missing terms, they'll keep adding plus 0x square plus 0x and all that. I don't do this. I think this is too babyish. For 8th standard, you can understand this. For the missing terms, sometimes they'll add 0x square, 0x and all that. I don't teach like that. Huh? No, 0x square meaning 0 only it is. The missing terms, they'll show with 0. Like if you have, I'm saying that because in case in your school your teacher fills the missing terms, then you shouldn't think that I have forgotten to mention that. See, supposing you have the dividend like 3x to the power 5 plus 4x squared minus 7, they'll fill the missing terms. 3x to the power 5, then plus 0x to the power 4, then plus 0x to the power 3, then 4x squared, understand? Plus 0x and then minus 7. This one I have not told you. Even if you don't do this, you will still get the correct answer. It's not that this is not mandatory. Sometimes if at all she teaches you division, she or he might introduce the missing terms like this. It is not needed. Online students, is the division clear?
Yes, ma'am.
Yes, ma'am.
All right. So to sum up, in today's class, we, we shared or we understood the 4 identities, the algebraic identities which you have for 8th standard. And then we also understood how to apply the identities when you have to expand an expression or when you have to find the value of a particular number like 103, find the value of 103 square. You understand, you can recall the different kind of products, numerical products you have to find. So there also you can use algebraic identities. You make that numerical expression look like a part of any of the identities, right? Yeah. So we understood the 4 identities. Then we use the identities to find the values of expressions or numbers. And then we understood how to perform division using algebraic expressions, dividing any number of terms by a single term, that is division by a monomial. And we also understood how to perform the long division when you have to divide by a binomial. Same procedure for a trinomial. Division by trinomial, similar procedure. All right, children. So that's it for today's session. Any questions? Online students, any questions?
No, ma'am.
No, ma'am.
All right. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, boys. Good night.
Thank you, ma'am.
Thank you, children. Good night.